So second part of section 5.7, still sequences, but now geometric sequences. So instead of adding or subtracting to get the consecutive terms in a sequence, we're going to be multiplying. A geometric sequence multiplies by what's called a common ratio. So which will be labeled as R as a symbol. So again, you're multiplying to get the next terms, right? The first 6 terms of the geometric sequence when the first term is 6. So remember, first term is a sub 1. It's still a sub 1, even if it's a geometric sequence. First term is a sub 1, and that's 6. And then the common ratio is 1/3. Remember, this is going to be referred to as R in like a formula or as a symbol. So 6 times a third. I'm going to just multiply as I go here. 6 times a third is 6/3, which is 2. And then 2 times a third is 2/3, right? And then 2/3 times a third. So remember, what I'm doing here is I'm just getting consecutive terms, right, in a geometric sequence. Common ratio is 1/3. That means I can multiply any term by 1/3 to get the next term. So anyhow, 2/3 times a third, that's going to be 2/9, and then I'm going to multiply 2/9 times a third to get the next term. 2 times 1, and then 9 times 3 is 27, 2 27ths. And see, I have the first term was 6, second term was 2. Let's see, 1, 2, 3, 4, 5. I need one more. I need this first 6 terms. So multiply 2 27ths by, again, a third. And 2 times 1 is 2. 27 times 3 is 81. So my first 6 terms, remember the first term is 6. So the first term was 6, and then I multiplied by a third. Second term is 2, and I kept multiplying by a third. 2/3 was the next term, then 2/9, then 2 27ths, then 2 81st, and again, that was my first 6 terms. All I had to really know how to do is multiply fractions once I understand how to use a geometric ratio sequence. This one, right, the first 6 terms, geometric sequence. First term is 12, common ratio is -1/2, so 12, then 12 times -1/2 is, you could show all your steps here and get -12/2, and that's -6, but you know, maybe simplify, do some mental math where possible. So -6 times -1/2, right, that's going to be a +3. 3 times -1/2 is -3/2. -3/2 times -1/2 is +3/4. 3/4 times -1/2 is -3/8, and I think that may be it. Let's see. First 6 terms. 1, 2, 3, 4, 5, 6. Yes, we're good. And again, those terms were, if I get rid of all this work, first 6 terms were 12, -6, 3, -3/2, 3/4, -3/8. So one thing you might notice is when you're multiplying by a negative number, when your common ratio is a negative number, your terms are going to alternate from positive to negative to positive to negative, and so on. Next, we have something similar to the arithmetic sequences, where if I'm not trying to get the first 6 terms or first 10 terms, or you know, some range where I have consecutive terms, if I'm just trying to get one term in particular, then the formula makes sense. So remember, in this formula, right, a sub n, right, that's just the nth term, right? A sub n is the nth term. Remember, a sub 1 is your first term. All these things are similar. R is different though, right? R is a common ratio. It's the number I multiply by. R is your common ratio. Oops. And then here, n minus 1, remember n is your term number, right? Term number is n. So, that says term. So some similarities, some differences between the arithmetic sequences. Anyhow, if I want to find the nth term, n equals 8, a sub 1 is -4, r equals -2. So I can just plug these in, guys. So again, n equals 8 means find the 8th term. So a sub 8 represents the 8th term. And then a sub 1 is here, right? It's -4 times r to the... Oh, one thing you want to make a note of this is raised to a power. R to the power of -1, so r is -2. And I'm going to raise that to the power of n minus 1. Remember, n was 8, so 8 minus 1. You guys could probably do this in your head, right? 8 minus 1 is 7, so I'm going to raise -2 to the 7th power on this one. -2 to the 7th power. Remember, if you're... Technically, we should put this in parentheses because we are raising the negative number to a power. So -4 times, if you raise -2 to the 7th power, a couple, whoops, let me get that on screen, sorry about that. Couple things you might know here is when you're raising a negative number to a power, if the exponent is odd, the answer will be negative. So -2 to the 7th power is -128, and then if I multiply -4 times -128, let's just have a calculator handy for that. 512. There's that one. This one over here, same thing. I'm going to use the formula a sub n when n is 12. So I want to find the 12th term. I'm going to multiply. Remember, a sub 1, that's -2. Times the common ratio 3/2 raised to the power of n minus 1. So I'm going to raise this to the power of 12 minus 1. So remember, 12 minus 1 is just going to be 11. You could do a little mental math there. So raising 3 over 2 to the 11th power is definitely not something you want to do by hand. So one way you could do it on your calculator is you can press... Like on this one, I can press 3 over 2, 3 divided by 2. In fact, I need to put parentheses, 3 divided by 2. I can raise that to the 11th power and get 86.4975. So I'm just going to round that to 86.5. And -2 times 86.5 is what I'll end with. So times -2, negative 172.9. So that's the 12th term in that sequence. So I went ahead and copied the formula onto the next problem. So same thing on this one, right? I'm being asked to find a specific term, the 7th term. So n equals 7. First term is 5, so a sub 1 is 5, and the common ratio r is -3, right? So I have all these values I can plug in. Trying to find the 7th term, a sub 7 equals a sub 1, so 5 times the common ratio -3 to the power of 7 minus 1, right? n minus 1 is 7 minus 1, so 6. -3 to the 6th power. Remember, that's if you're raising a negative number to a power, then if your exponent is even, the answer will be positive. So again, -3 to the 6th power is 729. So 5 times 729. So that is, again, have a calculator handy. 3,645. Again, that would be the 7th